Hi everyone. So we're starting chapter 3 today with section 3.1. So here you can see we're actually getting a little bit more detail with our rules over here. So we're actually introducing the law of signs over here. So mainly what happens in this section is we're actually going to be looking at how to solve triangles that do not have 90-degree angles in them. So no right angles. Of course, in chapter 1, we talked about how to solve right triangles. So now let's see how we can solve oblique triangles. So for oblique triangles, that basically means triangles that have no right angles in them. So you can have an acute angle in them. You can have an obtuse angle in them. They just won't be 90-degree angles. So again, remember we use capital letters to label our angles, and we use small letters for our sides, which would be opposite to those angles. So you can kind of see this little figure we have here. So for angle A, opposite side would be side A. And again, we use small letters for the sides, capital letters for the angles. Again, side B would be opposite to angle B, and side C would be opposite to angle C. Okay, so basically they are saying when you're trying to solve an oblique triangle, you need to know at least one of the sides, and then you need two more measurements. So either you can know that at least one side, and you know any of the other two sides, any of the two angles, or at least one angle and one side. So what that leads you to is then you can have two angles and one side, and then depending on the order of where those angles and sides are related, you can have angle side, or you can have angle side angle. The next case could be you're given two sides and an angle opposite to one of them, so that would be side angle. You can be given all three sides, so that's just SSS for the three sides. Or we could be given two sides and their included angle, so that would be side angle side. So for the first two cases are what we're going to be seeing in this section. So for the first two cases, we would be using law of sines. And then for the last two cases, we will be looking at law of cosines, which is going to be in the next section. So your law of sines is a pretty straightforward rule over here. So of course, like I said, this only works for as long as you don't have a 90-degree angle within your triangle. So you can have where angle A is an acute angle, or angle A is an obtuse angle, and your law of sines is side A divided by sine of angle A, which can be equal to side B divided by sine of angle B, which is equal to side C divided by sine of angle C. You can also actually look at the reciprocal form of the law of sines, and you can also write it in this way. So we're just inverting our fractions. Okay, so depending on which process helps you out, you can look at the law of sines with the sides being on the top, or you can look at the law of sines with the angles being on the top. And then again, in your textbook, they're actually showing you a proof for the law of sines if you wanted to take a look at it. So let's see how these law of sines will help us solve these oblique triangles. So in this first example, we are actually given two angles and one side. So this is one of our first cases, angle side. So they're telling us angle C is 102 degrees, angle B is 29. So those are going to be these angles right here. And we also know side B to be 28 feet, which is going to be this side over here. So they're asking us to find the remaining angle and the sides. So since two of your angles are given, right? And we know in a triangle, all three angles add up to 180 degrees. So you basically just take 180 degrees and subtract those given angles B and C from it. And then whatever answer is remaining is going to be your third angle. So angle A is now going to be 49 degrees. So as simple as that for finding the remaining angle. Now for finding the two missing sides, you are actually going to have to use the law of sines over here, and since we are trying to find the missing sides, we're going to put our sides on the top. So as you can see, for finding side A, we are looking at this form of our law of sine. So just using A over sine of A equals B over sine of B. We already know B is 28 feet. We know angle B is 29 degrees, so that's going to be sine of 29. And basically what they did here is they ended up multiplying that sine of A on both sides of our equation here. And of course, we just calculated angle A. So we know angle A is 49 degrees. You solve this little right-hand side here to find your side A. And side A comes out to be approximately 43.59 feet. So this guy here would be 43.59 feet. Okay, and in that same way, we are taking this form here, which is C over sine C equals B over sine B, and then again using our measurements for side B, angle B, and angle C, we are able to calculate side C, and side C comes out to be 56.49 feet, so that's going to be 56.49 feet. And you know, the one thing that might help you remember is that the longest side is going to be across from the largest angle. So that way you will kind of keep track of your calculation. So again, the longest side is always going to be opposite from the largest angle. Okay, so it's pretty straightforward how these law of sines work. Now this was a neat little information your textbook had. So they're saying in the 1850s, the surveyors used law of sines to basically calculate the height of Mount Everest, and they're saying their calculation was within 30 feet of the currently accepted value. So not too bad, right, for surveyors to do this calculation back in 1850 and to be within 30 feet of the height of Mount Everest. So I thought that was kind of a neat way to look at how these law of sines work in practical examples. All right, guys, so our example 1 here is again giving us two angles and one side, and they're asking us to find the remaining angle and the remaining sides. So let's go ahead and take a look at this example over here. So obviously you can see we are given angles A and B, which means we need to find angle C. And okay, so just my angle symbol. So to finding angle C, you will basically again take the idea that all three angles add up to 180 degrees. So that's going to be 180 degrees minus angle A minus angle B. So angle A is given to us as 30 degrees. Angle B is given as 45 degrees. So if you just go ahead and do that subtraction, of course, you should get 105 degrees for angle C. Okay, so that would be 105 degrees for that angle C. Now to find your missing sides, which we are given side A, so we have to find sides B and C. We can start by finding, I guess it really doesn't matter, but we can start by finding, let's say, side B. So since we're finding side B, you can actually set this up as B over sine of B equals A over sine of A. Now basically we're trying to find side B, so which means we'll go ahead and multiply both sides by sine of B. Okay, so multiply both sides by sine of B. It will cancel out on the left hand side, giving us b equals a divided by sine of a and then multiplied by sine of b. And let's see, we are given side A as 32 centimeters. Our angle A is 30 degrees. And then we're multiplying this by sine of B. Angle B is 45 degrees. So again, you can use your unit circle to help you out here. So sine of 30 degrees. And let me show you that. Oops, wrong one. There we go. So as you can see, your sine of 30 degrees is going to be 1/2. And then sine of 45 degrees is going to be square root of 2 over 2. Okay, so just a matter of cleaning this up. So you will have 32 divided by 1/2 would become the same thing as multiplied by square root of 2 over 2. Multiplied by 2 over 1 and then multiplied by square root of 2 over 2. So simplify this as much as you can. And in this case, I'm actually seeing a 2 on the top, a 2 on the bottom. So you can go ahead and cancel those out. And you would be left with 32 times square root of 2. Go ahead and multiply that. And you should get an approximate value of 45.25 centimeters, and this is going to be for our side B. Okay, so we have found side B, so the only other thing we need to find is going to be side C. So this guy is approximately 45.25 centimeters. So now let's look at side C. Side C, same thing, you can do C over sine of C equal to A over sine of A. Now you could use B over sine of B, but since we have an approximate answer for side B, I actually like to go back to the original values that were given to us, so that way you don't end up with rounding errors. So usually try and go back to the original angles and sides that were given to you. So just like we did with the previous side B, that's the same thing we're going to do here. Multiply both sides by sine of C. On the left hand side, these guys will cancel out, leaving us side C equals A over sine of A multiplied by sine of C. So again, our side A was 32 centimeters. Angle A was, of course, 30 degrees, and then angle C was the one we calculated, which came out to be 105 degrees. Okay. So again, we know sine of 30 degrees is going to be 1/2. Now, sine of 105, of course, you can see 105 is not one of the standard angles that we have. So you will actually need to just put that in your calculator and see what you come up with. So sine of 105 will end up giving you, make sure your calculator is in degree mode here. So you're going to actually get a pretty interesting number, 0.965292582 So obviously not a happy number, right? So let's go ahead and clean this up. You have 32 dividing by 1/2, so again multiplying by 2 over 1, and then multiplying by this sine of 105, and you can actually leave it as sine of 105 if you like. You don't have to write this decimal approximation. And then basically you're just multiplying everything. So go ahead and multiply that, and you will end up getting approximately 61.82 centimeters for your side C. So 61.82 centimeters. So now we have found our missing angle, and we have found our missing sides, and you can see this is where those law of sines come into play. Okay, so this was our example 1. Now for case number 1, again you can have a different order in which your two angles and one side is given. So this is two angles and one side where your side is actually going to be sandwiched between the two given angles. So this one here is talking about a pole tilts toward the sun at an angle of 8 degrees from the vertical. So you can see if we are talking about this little dotted line here being our vertical, we are saying it's tilting towards the sun at an angle of 8 degrees. They're telling you it is casting a 22-foot shadow. So that's this distance here, a 22-foot shadow. And they're telling us the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So that's going to be this angle right here. And they just want to know how tall the pole is going to be. Okay, so let's take a look at this. If you think about this pole, if the pole was standing straight upright, right, if it was not tilting or leaning, then you would have made a 90-degree angle. So this angle here is 90 degrees, and then if you add that tilt of 8 degrees together, this angle B comes out to be 98 degrees, right? So they're talking about this entire angle that you make from the pole all the way to the ground is going to end up being 98 degrees. We already know angle A is 43 degrees. So using those two angles, we can go ahead and calculate our angle C. So that would be 180 minus 43 minus 98, which would end up giving us 39 degrees for this angle C. We know side C, right, because that's the shadow, and we know it's 22 feet long. So you can basically use that information, and since we are talking about finding the height of the pole, that pole is across from angle A, so that's going to be our side A. So you're basically finding side A by using side C, and angle A, right? So back to law of sines, multiply both sides by sine of A over here, right? And you get A by itself, and then just plug in the values for all of these sides and angles, and you will end up getting approximately the height of the pole is 23.84 feet. So 23.84 feet is going to be the height of the pole. So we can use that same concept here in our example to find the height of the tree. So you can basically see that the tree is also leaning, right? And so it's actually making a 96-degree angle with the ground. Which I would imagine is the shadow of the tree is going to be 30 meters long. The angle of elevation from the tip of the shadow to the top of the tree is making a 23-degree angle, and we're basically interested in finding the height of the tree. So we want to know what is that H going to be. So let's go ahead and take a look at how we can solve this. So, it might actually help to assign some variables to our tree example over here. So how about we call this angle of 23 degrees as angle A. The angle that the tree is making with the ground, let's call that angle C. And then this angle on the top of the tree, we'll call it angle B. Okay, so automatically the side across from side C, angle C, will become side C. So this guy will become side C. The side opposite from angle B will become side B. And then that means the height of the tree, they're calling it H, but just to use our letters here, that would be side A, but let's keep it as H to kind of follow along with our example here. So the first thing we're actually going to do is, since we know two of the sides, two of the angles of our triangle, we can actually go ahead and find what angle B is going to be. So to find angle B, again, same thing, we take 180 degrees minus the 96 degrees minus 23 degrees. So when you go ahead and do that subtraction, you should get angle B as 61 degrees. So this angle here will be 61 degrees. Okay. Now, since we are interested in finding side A, or the height of the tree, and we are given side B, you can basically use the law of sines for that. So we can do A over sine of angle A equals B over sine of angle B. But remember, A is the same thing as H because that's the height of our tree. Sine of angle A is 23 degrees. Side B is 30 meters. And of course, sine of angle B will be 61 degrees. So the first thing I'm actually going to do is go ahead and multiply both sides by sine of the 23 degrees. Get our H by itself. And then you're basically multiplying 30 over sine of 61 with sine of 23 degrees. Now, I would probably just put all of this in my calculator. So you can start by taking 30 divided by sine of 61 degrees. And then the answer you get, go ahead and multiply it with sine of 23 degrees. And you should get approximately a height for our tree as 13.40 meters. So we're basically saying the height of our tree is going to be 13.40 meters. I'm not sure why I left such a big gap in there. Okay, so that's the height of the tree. Okay, so not too bad. So this was our example 2. So this was looking at those first cases we were talking about. Let me show you that one more time. So the 2 examples we have done was based on this case 1 over here. So where you are given 2 angles and 1 side. Now, when we are talking about the ambiguous case, we're actually getting into this second case over here, where you are given 2 sides and an angle opposite to one of those sides. So let's take a look at what happens here. Okay, so this is where we're talking about the ambiguous case. So when 2 sides and an angle opposite to them are given, you can actually have 3 possible situations that can occur. You either have no triangle, which would exist given those measurements, and we'll look at examples of that. Or you can have a possibility of just 1 triangle which would exist. Or you can actually have 2 distinct triangles which would also end up satisfying your condition. So you can end up with no triangle, 1 triangle, or 2 distinct triangles which would satisfy those conditions. So just as an illustration, you can kind of take a look over here. So they're saying, consider that you are given the sides A and B and angle A. And they are defining this height of some of these triangles as H equals B times sine of angle A. They're basically using the sign definition here, opposite over adjacent, to come up with that. Because think about it, if this is angle A, and I'm just looking at this first triangle over here, if this is angle A, then that's going to be opposite divided by the hypotenuse, right? And so that's basically just the modified version of our sine of angle A equals opposite over adjacent. So they're saying if you have an acute angle where your side A is less than your side H, that perpendicular in the middle, you will actually have no triangle which would satisfy that condition. Again, in an acute angle, if your side A is equal to the height of your triangle, then you can get one triangle which would satisfy your condition. If you have an acute angle where side A is either greater than or equal to side B, then again you can come up with one triangle which satisfies the condition. In an acute angle, again, if your H value is going to be less than A and A is going to be less than B, then you can actually come up with two possible triangles. Now, if your angle A is an obtuse angle, right, which means greater than 90 degrees, in that case, your A value has to either be less than or equal to B, and in that case, you would actually come up with no triangle either, which would satisfy that. Or in an obtuse triangle where angle A is greater than 90 degrees, your A value has to be greater than B, and you can come up with one triangle. So depending on which kind of triangle you have and what condition you are given, you may have a triangle or you may have none. Okay, so here we're looking at the single case solution where you are given two sides. So we are given side A, we are given side B, and we're given an angle opposite to side A. So that's angle A, which is given to us. So again, obviously we're finding the remaining side and the angle. So since we are actually given two sides and one angle, we have side A, we have angle A, and of course we have side B. So based on that, we can actually calculate our angle B. So you can say we are getting sine of B by itself. We take the side or little b to the other side by multiplication, plug in your values, and then once you solve that, you are able to calculate for your angle B. Now remember, of course, you would have to use the sine inverse function to get angle B by itself, but you end up getting approximately 21.41. So that's going to be this angle here, 21.41 degrees, and then subtracting the two given angles from 180 degrees, we can find that missing angle C, which is 116.59 degrees. So we can go ahead and find our missing angles, and then the only thing left to find is side C. And again, you can see we are using the law of sines over here, going through our calculations, and you get side C as 29.40 inches. So that's 29.40 inches on your side C. So there's, like they said, there's only one triangle that would satisfy these conditions. So let's take a look at our example 3 over here. Again, we're given one angle and we're given two sides, and we have to find the remaining side and angles. Okay, so we are given angle A is 31 degrees. So this is just going to be a rough sketch. It's probably not going to be very accurate. Okay, so we are given angle A is 31 degrees, side A is 12 inches, and side B is 5 inches. So we have to find side C and we have to find angles B and C, right? So let's take a look at how we can go about doing this. So how about we start by finding angle B. So let's talk about finding angle B over here. So I'm actually going to, since we're finding the angles, we are going to do the reciprocal version of our law of sines, right? So we're going to put angles on the top, sides on the bottom. And of course, since we are given side and angle A, we're going to set that on the right hand side. So we know we need to get sine of B by itself. So we can go ahead and multiply side B on both sides. Get sine of B by itself, and then you have sine of A divided by side A multiplied by side B. So let's see, sine of angle A is 31 degrees. Side A is 12 inches. Side B is 5 inches. So you can go ahead and put all of this in your calculator and see what you come up with. Again, make sure your calculator is still in degree mode. So that's sine of 31 divided by 12 and then multiplied by 5. This right hand side ends up coming out to be 0.214599,198, and this is obviously still equal to sine of angle B, right? So if you want to get B by itself, you're going to have to use sine inverse on the other side. And then once you do sine inverse on this number, you will be able to get your measurement for angle B. And of course, we're rounding this to 2 decimal places, so that will come out to be 12.39 degrees. And this is how you find your angle B. So 12.39 degrees for this guy. Now that we have the two angles, you can find angle C pretty easily. So for angle C, we basically just need to take 180 degrees minus angle A minus angle B. So that would be 180 degrees minus 31 degrees minus 12.39 degrees. And that comes out to be 136.61 degrees for angle C. So once you find, you have two known angles, finding the third one is pretty straightforward. So 136.61 degrees. So we have both our angles. All we have to do now is find our missing side C. So for side C, we will use law of sines here again. So we'll have side C over sine of angle C, and is equal to, I'm actually going to go and fall back to my side A and angle A. So A over sine of angle A. Since we want to get side C by itself, I'm going to multiply sine of C on both sides, cancel it out, and you get side C equals A over sine of A multiplied by sine of C. So of course our side A is 12 inches, angle A is 31 degrees, and then angle C we just calculated was 136.61 degrees. So just plug that part in your calculator and see what you come up with. So let me see, when we round this to 2 decimal places, our side C comes out to be 16.01, and of course we're measuring sides in inches in this example, so 16.01 inches. Okay, there you go. So that's how you find your missing angles and your missing side. So this was the case where you have exactly one triangle, which will be your answer. But what happens if you end up with a situation where you have no solution? You don't find a single triangle. So let's look at this example over here. We are given side A is 15 feet, side B is 25 feet, and they're telling us angle A is 85 degrees. So kind of visualizing is a great idea, because you can kind of see what's going on with your information that's given to you. So we sketch our little triangle here first. And they're saying from this figure, it appears that no triangle is possible. Now you can of course see, if you draw a perpendicular line here, this side H is going to be longer than side A. So since side A is smaller in length than side H, you're going to have no solution, because remember that was that first case that we were looking at here in this little box we had. So that's actually the kind of triangle we have ended up with. And you can try and verify this by using the law of sines. So since they are giving us side A, side B, and angle A, we can use sides A and B to help us out. So you've got sine of B over B equal to sine of A over A. And we're obviously at this point trying to find what sine of B or angle B is going to be. So just take a look at this here. So we're given side B is 25 feet, side A is 15 feet, and of course angle A is 85 degrees. So when we put this in our calculator, you end up getting the value of sine B as 1.6603. Now you have to remember here that sine only goes from -1 to +1, because that's the range of the sine function. So the range of the sine function only goes from -1 to +1, and obviously you can see this number is greater than 1. So this is actually falling outside of the range of the sine function. So that's why you are going to have no triangle with these conditions that are given to you. So we cannot solve this triangle. There's no solution. So same kind of thing we have to do for example 4 here. They're saying that show that there is no triangle for which A equals 4 feet, B equals 14 feet, and A equals 60 degrees. So let's go ahead and take a look at what happens here. Okay, so if we try to draw a triangle from the information that's given to us. Okay, so let's say this is angle A, angle B, angle C. They're telling us angle A is 60 degrees. Side A is actually going to be shorter than that, is only 4 feet. And side B is 14 feet. Okay? So here again, if we draw a perpendicular coming down, again you will see our side A is going to be shorter in height or in length than our side H, or the height of the triangle. So this itself is not meeting the condition, so it's not going to work. But of course we want to verify this algebraically. So let's go ahead and use our law of sines here again. So let's do sine of B over side B equals sine of A over side A. Go ahead and multiply both sides by side B, since we want to get sine of angle B by itself. Sine of A would of course be sine of 60 degrees. Side A is 4 feet. Side B is 14 feet. So if you just try to solve that right hand side sine of 60, of course you can use a unit circle for that, or you can just use your calculator. It's going to be square root of 3 over 2, which is being divided by 4 and multiplied by 14. So if you just solve that, you actually end up with square root of 3 over 2 multiplied by 1/4 multiplied by 14. If you just go ahead and kind of sort this out, this guy comes out to be approximately 3.03108, and I think it just will keep going. So right here you can again see this is going outside of the range of our sine of b. So again, this value here is greater than 1, outside the range of the sine function. But if you don't catch that, and let's say you decide, okay, I'm going to do b for my angle and do sine inverse on this number, you should actually see an error message on your calculator. So go ahead, verify that, just so you know that you are comfortable doing these calculations and you know what kind of answers you get. And of course you should get a domain error, right? Because it's not going to be in the domain of the inverse function. So again, this is not going to be formed. So you can say no triangle can be formed with A being 4 feet, B being 14 feet, and angle A being 60 degrees. Okay, so I hope you can kind of see how this process works out where you are not able to come up with the triangle. And the main part is you're going to end up being outside the range of your sine function. Okay, so that was example number 4. Now, for that same case where you have two sides and one angle, let's take a look at under what conditions do you end up getting two distinct triangles as your answer. So our example here is telling us we have A equals 12 meters, B equals 31 meters, and angle A is given to us as 20.50 degrees. So what they're actually doing is starting out by using this calculation here, H equals side B times sine of angle A. So multiplying those values together ends up giving us a side H as 10.86 meters. So you can see 10.86 meters is going to be smaller than 12 meters and smaller than 31 meters, right? So H is smaller than A is smaller than B. And this happens, let me show you that. This happens right here for this acute angle where you have H less than A less than B, and that's when you get your two possible triangles. So that's kind of where we are at in this example. So using our law of sines, we are finding angle B. And in this case, what's going to happen is sine of B is coming out to be 0.9047, and there are actually going to be two angles which will satisfy this, because sine of 0.9047 is smaller than sine of an angle at 1, right? Because when you're talking about sine being a value of 1, you're looking at pi, and well, that's actually going to be between 0 and pi, where you should have two angles which will have values less than 1, right? Because right here at pi halves it's 1, so you should have 1 from each quadrant over here. So if you actually calculate sine inverse on 0.9047, you should get approximately 64.78. And then subtracting that angle from 180 degrees, you can actually come up with your second angle B, which will satisfy the same condition. And that's going to be because anywhere between quadrants 1 and 2, your sine value is going to be less than 0.90, or approximately close to 0.9047. So you can come up with two angles, and then based on each of these angles, you can come up with two different calculations for your angle C and your side C. So based on which angle measurement you are using, you can come up with two different values. That gives you two different triangles. So you can see this is coming from our B1 angle and this is coming from our B2 angle, and how those two different triangles end up looking like. Okay, so let's try and use this same idea in our example 5 over here. We are given A equals 4.5 feet, B equals 5 feet, and of course angle A is 58 degrees. So the first thing we are actually going to do is also calculate our H value. So that's H equals B times sine of angle A. So B is 5 feet. Sine of angle A is 58 degrees. So go ahead and multiply that, and we will get an approximate value of 4.24 feet. So 4.24 is of course less than 4.5 and less than 5. So we can again say that H is less than A and A is less than B, which means this can lead us into getting two possible triangles. Okay, so let's talk about finding that angle B. So we are going to do sine of B over side B equals sine of A over side A. Okay, so we'll need to multiply that small b on both sides. Get sine of B by itself, and then let's see what this right hand side gives us. So sine of A would be 58 degree angle, side A is 4.5 feet, side B is 5 feet. So if you do sine of 58 degrees divided by 4.5 multiplied by 5, this is giving you an approximate value of 0.9423, just rounding it to 4 decimal places. So again, it's actually going to be the same thing. These angles, you will basically be able to find two angles which would satisfy this condition. So we will end up doing angle B is sine inverse, but I'm actually going to leave all my decimal places here because I don't want to use a rounded answer. So when we do sine inverse on this answer, you actually end up getting angle B as 70.44 degrees, but we're actually going to call this as angle B1. Okay, to find angle B2, we will of course do 180 degrees minus 70.44 degrees, which will end up giving us 109.56. and this will be our angle B2. Okay, and then once you have these two angles, you can go ahead and find your angle C and side C. So let's go ahead and separate these. So for angle B1, for angle C, it's going to be 180 degrees minus angle A, which was 58 degrees, minus 70.44, which will end up giving us 51.56 degrees. And now that we have our angle C, we can go ahead and find our side C. So that would be side C over sine of C equals A over sine of A. Multiply both sides by sine C, so you should end up getting A over sine A multiplied by sine C, which will be side A is 4.5 feet, sine of 58 degrees multiplied by sine, oops, not enough space, okay. Let's do that here. So 4.5 over sine of 58 degrees multiplied by sine of 51.56 degrees, and let's see what that comes out to be. Okay, so it looks like it's coming out to be approximately 4.16, and of course this is in feet. So this is angle C, this is side C. Okay, but what if you were using angle B2, which is 109.56 degrees? So angle C would then be 180 degrees minus 58 degrees minus 109.56 degrees. So angle C will be a very small angle because this guy comes out to be 12.44 degrees. Okay, now for side C, again, okay, so this time we will have side C as A over sine of A times sine of C. A again is 4.5 sine of 58 degrees, but now we are multiplying with sine of 12.44 degrees. And this guy will end up giving us approximately 1.14 feet. So that was for side C. This was for angle C. Okay, so you can see we end up getting pretty different triangles because you are going to have an acute angle here, maybe, and this is just going to be a rough sketch here, not very accurate, but this guy might end up being, so we were given 58 degrees, And then let's see, 70.44 for this guy, and 51.56 for this guy, right? Side A was 4.5 feet, side B was 5 feet, and side C came out to be 4.16 feet, whereas on the other side, we had, again, this is a very rough graph here, folks. So let's see, this guy is still 58 degrees, but then our angle B2 was 109.56, and angle C, of course, just came out to be 12.44 degrees, and then side A was 4.5 feet, side B was 5 feet, but then side C, just came out to be 1.14 feet, right? So you can see how different those triangles would end up looking like, but obviously you can get two distinct triangles when you meet these conditions, okay? So this was the third situation that you can get when you are looking at given two sides and one angle. So we have looked at each one of these cases just so you know when we have no triangle, one triangle, or two distinct triangles, okay? Alright guys, the next thing we want to talk about is how we can find the area of these oblique triangles. So basically they're saying the area used to prove the law of sines actually leads to a formula for the area of an oblique triangle. So we've got our acute angle A or obtuse angle A triangles over here. For each one of these, the height of the triangle can be calculated again using H equals B times sine of A, right? Because this is angle A. So if we talk about sine, that's opposite over hypotenuse. So if you do sine of A, that's opposite over hypotenuse. If I multiply both sides by B, I end up getting H equals B times sine of A, and that's exactly how they came up with this formula over here, okay? And the same thing you can verify with this triangle here with respect to angle A. So when we're talking about the area of a triangle, remember area of a triangle is always 1/2 base times height. So if you look at both these triangles, our base is going to be side C, right? So you've got that 1/2. For the base, we are using side C. And then for the height, we are talking about this distance H as our height. And H, of course, equals B times sine of A. So when you multiply this, you get 1/2 BC sine A. And just as a remark here, they're talking about you can also obtain the height of the obtuse triangle by actually using the reference angle 180 degrees minus A. And then what's happening here for this part, you are actually using the difference formula that we saw, what was that section, I think it was 2.3 or 2.4 where we talked about the difference formula. So you're then breaking it up into sine of 180 cosine of A minus cosine of 180 sine of A. Sine of 180 is of course going to be 0 because that's at pi. Cosine of 180 would be -1, and just simplifying that, you can see this ends up getting you to that same result, H equals B times sine of A, which is what we already had here. So they're just kind of showing you how you can come up with that calculation by using this reference angle. Okay, so coming back to the area of our triangle, we have area equals 1/2 BC sine A, but you can actually show that same thing is going to be true for the other sides and other angles. So you can have 1/2 BC sine A, or you can have 1/2 AB sine C, or you can have 1/2 AC sine B. So the easiest thing to remember is the angle that you use the other two sides. If I'm using angle A, I'm using sides B and C. If I'm using angle C, it's sides A and B. If I'm using angle B, it's sides A and C. So that's kind of how these area for the oblique triangles work out. And then they are saying if you have a 90-degree angle, this formula would actually still work, because at 90 degrees, your sine of 90 degrees, of course, is +1. And so this guy would just end up becoming +1, and your area would just end up becoming 1/2 B, or B times C, which is basically your 1/2 base times height in a 90-degree triangle. So yeah, I mean, you can kind of use this for oblique triangles, but it also works for a right triangle. So let's put this formula into use. So we're given this triangle over here, which has length, two of the lengths given to us as 90 meters and 52 meters. And the angle that's included between them is 102 degrees. So we're using 1/2 A times B multiplied by sine of C. So sides A and B are 90 degrees and 90 meters and 52 meters. So that's 1/2 90 times 52 times sine of that angle 102. And it comes out to be approximately 2,289 square meters. Remember, this is area, so you have to write your units as square units. Okay, so let's look at what our example here ends up looking like. So find the area of a triangular lot with two sides of lengths 24 yards and 18 yards and an included angle of 80 degrees. Okay, so if we are talking about triangle here, let's go ahead and get some illustration. Okay, so let's say these are our angles. This will be our side. We are given an angle of 80 degrees. So let's say it's this angle here, which is 80 degrees. And we are given the two sides around it. So that would be 24 yards. And the other one was 18 yards. Okay, so if we had to write this as a formula, our area of the triangular lot would end up becoming 1/2 sides A times C multiplied by sine of angle B. Okay, so that would be 1/2 18 times 24 times sine of 80 degrees. Now, of course, you can just plug all of this in your calculator and go about solving it. Just to simplify, you can also get rid of that that 2 that goes into 18 9 times, and you can kind of clean it up like that. Or you could have also canceled out with the 24, it wouldn't have mattered. And then you are just multiplying all of these values. Like I said, you can also leave it the original form and still get the area this way. So this comes out to be approximately 212.7. So rounding it to a whole number, we can say this is 213 square yards, or you can write it out as square yards, however you want to do that. Okay, so this is going to be the area of our triangular lot. So not too bad. Okay, so kind of look through that. Alrighty guys, so the last thing we want to talk about is just an application where we can use these idea of law of sines. So they're telling us a course for a boat race starts at point A. It proceeds in the direction of 52 degrees southwest, so it's coming 52 degrees to point B. Now remember, these bearing angles are always done with respect to the vertical north-south line, so that's why this guy here is your angle 52 degrees, and then from point B we are headed southeast at a 40-degree angle to point C. So that's where this 40-degree angle is coming, because again it's with respect to that vertical north-south line, and then of course we're heading back to point A. So they're telling us point C lies exactly 8 kilometers south of point A, and they want to know what is going to be the approximate total distance for this race course. So as you can see over here, we're talking about our lines B and D and A and C are parallel. So basically we're talking about these two lines being parallel to each other. So since those lines are parallel, you can basically say that angle BCA, which is this angle here, is going to be congruent to angle CBD, which is going to be this, which means if these two angles are congruent, then this angle is also going to be a 40-degree angle. Now if this angle is 40 degrees, this angle here is 52 degrees, then you can actually find this angle inside our triangle. So that's going to be the 180 minus 52 minus 40, which will end up giving you 88 degrees right over here. So once you have, so basically this guy right here is your 88-degree angle. So now that we know that the distance A to C is going to be 8 kilometers, you can think of that as being side B, which is 8 kilometers right here. And then based on these formulas, you can actually go ahead and calculate your missing side A and C. So that comes out to be 6.31 kilometers for side A, and side A actually will be this one here. So this guy is coming out to be 6.31 kilometers, and then side C comes out to be 5.15 kilometers. So that's 5.15 kilometers here, and then you can add all of those three sides to get the total distance that this race was going to be for. So you're getting approximately 19.46 as the total distance for our race course. So just kind of using the same techniques that we did in our first couple examples to come up with the missing measurements. Okay, but this time we're doing it with the sense of the bearing angle. Alrighty, so let's take a look at our example here. They're telling us on a small lake, you swim from point A to point B, which is a bearing of northeast of 28 degrees. So that's this angle 28 degrees here. Then from point B, we are swimming to point C, which is going to be northwest 58 degrees. So that's this angle right here. And then of course we swim back to point A where we started out at, and they're telling us point C lies 800 meters directly north of point A. So that's our 800 meters here. And it's very similar to what we just saw in example 7. They want to know what's the approximate total distance that we swam from point A to point B to point C. So let's go ahead and take a look at this example over here. So let's go ahead and see what information we can gather from this side. Okay, so if you talk about lines AC and BD, so that would be this line here and this line here. they're going to be parallel to each other. So if they are parallel to each other, then your angle DBC, which is this angle here, is 58 degrees, is going to be congruent to angle BCA. So BCA is going to be this angle here, which will also be 58 degrees. Okay, so they're both going to be 58 degrees. Now that we have inside our triangle, so now let's look at inside our triangle ABC. We can now find the angle B measurement, right? Angle B can be 180 degrees minus angle A minus angle C. Angle A is already given to us as 28 degrees. Angle C we just calculated to be 58 degrees. So when you go ahead and make that subtraction, you should get the answer of 94 degrees. So this angle here for angle B should be 94 degrees. So we have all three angles inside our triangle. Now we can go ahead and find the sides. So this is side C, this is side A, and 800 meters is actually going to be side B. So if you want to find side A, we are going to use A over sine of A equals B over sine of B. So A we don't know. We're going to multiply both sides by sine of A. So these guys cancel out, giving us A equals B over sine of B multiplied by sine of A. So side B, of course, is our 800 meters. Angle B is our 94 degrees, so that will be sine of 94 degrees, and then we're multiplying this with sine of angle A, which is 28 degrees. So again, just plug this into your calculator and you should get approximately side A to be 376.49 meters. Okay, so 376.49, so that's going to be this distance here, side A, 376.49 meters. Now we have to find side C, so let's go ahead and do that. So again, that would be C on the top, sine of angle C on the bottom, and side B on the top, sine of angle B on the bottom. Multiply both sides by sine of C. So we will get C equals B over sine of B times sine of C. B, of course, is our 800 meters. Sine of B is going to be our sine of 94 degrees, and then of course sine of angle C. Angle C was that congruent angle, so that's going to be 58 degrees. So again, throw that into your calculator and you should end up getting side C as approximately being 680.10 meters. So 680.10 meters. And now to find the total distance, you just add all three of those sides. Okay. So A plus B plus C. Side A is 376.49 0.49 meters. Side B is 800 meters. And side C was 680.10. So when you add all of these numbers together, we should get a total of 1,856.59 meters. So that's how much we are swimming a total distance of here. Okay, so again, just using our law of sines to help us out here. So you should kind of get a feel for what these problems look like. So again, guys, look through these examples. Let me know if you have any questions. We'll talk about these in class, and be careful, take care of yourselves, and I'll see you in class next time. Alright guys, have a great day. Bye-bye.